We can use double angles to verify trigonometric identities, same as we can any other kind of identity. You might notice I don't actually have a double angle in here. What I have is sine of 3x. Well, I don't have an identity for that. So what I'm going to do is rewrite 3x, and I am going to go ahead and start on the left side. Sometimes we like to start on the side that's more complicated, which is probably the right. But even though the left-hand side is simpler, there's more things that I can do with it. So I'm going to rewrite sine of 3x as sine of 2x plus x. So that's still sine of 3x. I've just spread it out a little bit. But now I've turned it into something that I have identities for. I have an identity for the sine of a sum. So I'm going to use that. That's going to go sine of the first thing, cosine of the second, plus cosine of the first thing, sine of the second. Okay, well, we don't look that much closer to where we want to be yet, but we'll keep going, because now I have some double angles. I have sine 2x, I have cosine 2x. We have identities for each of those. Sine of 2x is 2 times sine x times cosine x. And then I still have the cosine x that was there at the beginning. Cosine of 2x, we have 3 choices for an identity for cosine of 2x. So I'm going to look at what I'm aiming for over here on the right, and notice there are only sines in there, not a cosine to be seen anywhere. So I'm going to use the version of cosine 2x that has only sines in it, which is 1 minus 2 sine squared x, and then times the sine x that's already there. All right, well, there's some simplifying we can do here. I got 2 sine x. This is cosine squared x. And we can distribute plus sine x minus, let's see, sine squared times another sine is, we got 2 sine cubed x. And that's a good thing, because we're aiming eventually for sine squared x, and we didn't have that before. Okay, so now I have sine cubed. Is that better? Yeah, it's better. We're not there yet, but we have a feeling we might be moving in the right direction, at least. All right, now what? Well, as mentioned before, in the end, I don't want cosines. What I'm aiming for has only sines. So I'm going to use the Pythagorean identity and substitute 1 minus sine squared x here. So 2 sine x times 1 minus sine squared x. And, well, there's not really anything to do with the rest of this other than keep writing it. It's still there, but we don't have anything else to do with it yet. So now I'm going to distribute my left-hand term. I got 2 sine x minus, and this will be, I have sine times sine squared is sine cubed. And the rest of this stuff that's just hanging on. Now we have like terms. Before we didn't, now we do. I got a couple of terms that have sine cubed in them, a couple of terms that have sine x in them. Let's combine. I have 2 sine x plus another sine x. That sounds like 3 to me. And negative 2 minus 2 is minus 4 sine cubed x. So I'm still not quite there, but I can see the 3 and I can see the minus 4, that I'm aiming for. One last step then. I have two terms. They both have sine x in them. I'm going to factor that out. When I factor out sine x, from the first term I have left 3. From the second term I have the 4, minus 4, and 2 more sines. And that's what we wanted. We did it.